Hi everyone, in this video we will be looking at vectors. What is a vector, how to write a vector, to find the magnitude of a vector. So the first part in vectors essentially is what we're looking at in this video. So what is a vector? A vector is a quantity that has both magnitude and direction. So magnitude means size, right? So a vector has both size and direction, right? So vectors are normally used to represent displacement, velocity, acceleration, weight. Person to do physics deal with vectors a lot, right? So now we're going to look at the mathematical part in vectors. So how do we write vectors? So vectors can be named using two letters. So for example, we can have vector AB like what I have here. So vector AB, the way we would write vector AB just as you see it right there. So vector AB, write A and B and the line at the top, right? So that's vector AB. If I had vector PQ, so PQ, vector PQ, the line at the top, vector MN, right? And with the arrow at the top, and that's basically it, right? So it can be written using two letters with the arrow indicating the direction of the vector. Vectors can also be written as a single bold letter, as we have here and here, or we can have the single bold letter with the line underneath the letter, right? So you're going to see different variations coming up in different questions. So now vectors, look at the examples of vectors here. In the first example, we have vector AB is 2, 1. And number 2, vector X is negative 5, 11. Number 3, vector PQ is 0, negative 2. And number 4, vector R is 3, 7. Now something to notice, these are how vectors are written. Vectors are written as column matrices. And the first number represents the X value, the second number represents the Y value, right? So this is how a vector is written, right? It's a column matrix essentially, and the top number represents the X and the bottom number represents the Y, right? So that's basically how vectors are written. So now we're looking at something called position vectors. A position vector or position vectors are vectors that start from the origin. The origin is at the 0, 0 mark, which is right in the middle there, right? X is 0, Y is 0, right? Now from this diagram here, we have the coordinates of point A, which is right here, put a little X there. So the coordinates of A are 3, 7, right? And the coordinates of B are 4, right? Now, if you look carefully, a position vector starts from the origin, so therefore, vector OA, that's a position vector. Position vectors always start with O at the front, right? Because the O tells you that starts from the origin. So therefore, essentially, vector OA, the vector is 3, 7. You write it coming down as the column matrix, right? And then, likewise, vector OB, right? The value will be 8, 4. Right, so those two OA and vector vector OB, are both position vectors because they start from the origin O, right? And now let's look at another question here. We have, well, here they told us the position vector of P is 4, 3, and the position vector of Q is negative 2, 5. Right, you have a diagram here, they're showing it O, Q, so OQ is negative 2, 5. And OP is 4, 3, right? So the coordinates of Q are, right? It's negative 2, 5, and the coordinates of P is 4, 3, right? Now, as the position vector, OQ, negative 2, 5 coming down as the column matrix, and likewise for OP, right? 4, 3 coming down. So just little things to remember, and it's good to note this because when we start doing the past paper questions later on, this is something very important to remember, okay? So now we're looking at finding the magnitude of a vector. Now, as we mentioned at the beginning of the video, the magnitude of a vector is the size of the vector. So now, finding the magnitude of the vector is really finding the size of the vector, right? Now, again, so the general form, if vector AB is xy, then the magnitude of this vector, so you see already magnitude, you put your two lines, you put the vector in the middle, and it's the square root of the top number, which is the x value squared, square root of x squared plus y squared, right? Now, if you forget to put those two lines and all that, you honestly, you could just write magnitude of vector of, right? Just in case you forget, that's all right. So let's get to say these examples here. I'm going to work them all together. Find the magnitude of the following vectors. So we just learned it's the square root of x squared plus y squared, right? So in this case, our x value is 2, so it's 2 squared plus 5 squared. So it's the square root of 4, 2 squared is 2 by 2, plus 5 squared, which is 5 by 5, 25, right? So it's the square root of 29. And you can just put units. You could work it out what the square root of 29 is. You could leave it just like that. Right? That's fine. Now, the rest of the questions that we're going to do, you could pause the video, try it on your own because it's the same thing over and over, right? We want to find the magnitude for number 2 of vector PQ. So again, the square root of x squared plus y squared. Now, here we have some negative values. So that's negative 4 squared plus 7 squared. Now you need to remember that negative 4 squared is the same as negative. So therefore this is really 16 plus 28. Why am I saying 28? 16 plus 49. My bad. I was thinking about 4 times 7. Right, so negative 4 squared is 16 and 7 squared is 7 by 7. Which is 49, right? So 49, and again, you just add the two numbers, right? So we get 65, square root of 65 units, right? Again, you could use a calculator, and we could work it out. All right, let's look at the last two, or last three. Let's look at these tier 2 first. So here again, square root of x squared plus y squared minus 2 squared plus minus 3 squared. So that would be minus 2 squared is minus 2 times minus 2, which is positive 4, plus minus 3 squared is minus 3 times minus 3, which is positive 9. So you're going to get the square root of 13, and you can just put units at the end. All right, number 4. So the magnitude of vector LM. Right, same thing again, x squared, square root of x squared plus y squared. So it's the square root of 3 squared plus negative 9 squared. So 3 squared is 3 by 3, which is 9, plus negative 9 squared is negative 9 by negative 9, positive 81, right? So that's 81, so this will be the square root of 90 units, right? So you see it's not hard at all, right? And let's just look at the last one. So the magnitude of vector J, so the square root of x squared plus y squared. So that would be negative 1 squared plus negative 4 squared. Negative 1 squared is positive 1 plus negative 4 squared is positive 16. So we get the square root of 17, and you can put your units there. Right, so very easy to find the magnitude of our vector. So in our next video, we will go on to addition and so on, the subtraction with the vectors, and then we eventually will get to the CSEC questions as well.